Hey guys, this is Carrie, and this is the answer key to the group quiz. So, generate the first four terms of the recursive sequence described by the equations below. So we want A1, A2, A3, and A4. A1 is given to us as 3. All recursive sequences require an initial condition and a rule for generating the next term. So if we want to find A2, we're plugging in 2 for n here, which means we plug in 2 for all n's. So 2, a sub 2 minus 1 minus 1. A sub 2 is equal to 2, evaluating the subscript a1 minus 1. A2 is equal to 2 times, looking up a1 from the table, 3 minus 1, we get 5. Next, we do it for n equals 3. So we plug in 3 for n, and we get a3 is equal to 2 times a3 minus 1 is 2 minus 1. So 2 times a2 minus 1 is 9. And continuing this pattern, we get 2 times a3 minus 1 is 17. Generate the first four terms of the recursive sequence described by the equations below. Same problem, a little more challenging this time. A1 is 5. Now we do the exact same thing. To get a sub 2, we plug in 2 for all of the n's. So a2 is equal to 2 minus 1 times a sub 2 minus 1. a2 is equal to 1 times a sub 1, which is 1 times 5. Next up, we do the same thing with 3. So to get a sub 3, we plug in 3. So we get 2 times a sub 2, which is 10. And now we do the same thing with 4. A4 is equal to 3 times a sub 3, so 30. Consider the sequence shown below. Which of the following is A530, the 530th term in the sequence? So here's A1, here's A2, here's A3, here's A4. Fast forward, we want A530. So thinking about this, it's a little bit complex to go all the way to 530. So maybe what we do is we think to get to A4, we start at 9, and the pattern here is that we add 4 3 times. To get to A5, we'd have to start at 9, and we'd have to add 4 times. So to get to A530, we have to start at 9, and we have to add 4 529 times. So that looks like it will give us the results, and I don't have my calculator, so I'll leave the rest for you guys to figure out. Consider the sequence shown below. Which of the following is the value of a sub 10? Okay, so with these it can be a little bit tricky to see right away, so I would begin by generating the pattern. So a1 is 4. a2 is equal to 2 times a2 minus 1, 2 times a1, which is going to be 8. a3 is equal to 2 times a3 minus 1, which is 2, which is 16. A4 is equal to 2 times A3, which is 32. So it looks like the pattern is times 2. So now, to get the explicit formula, we could say that A10 is equal to start at 4, and we want to go times 2 a bunch of times. To get to A4, there are 3 steps. To get to A10, there are 9 steps, and so we do this calculation, and whatever you get from that is your answer, but you have to do it. For problem 5, an arithmetic sequence has a first term of 20 and a fourth term of 38. Determine an explicit formula for a sub n, the nth term of the sequence. So this one is a little bit tricky. It's a problem-solving type question where you haven't seen a problem like this before. But we know that A1 is 20. We don't know A2. We don't know A3, but we do know A4 is 38. Now they tell us a little bit of extra information. They said it's an arithmetic sequence, which means we're adding some amount each time. So there are a variety of ways that you could solve for this amount. Perhaps the easiest one to me is an algebraic one, where we could say, if we take 20 and we add x 3 times, it gives us 38. Now, a lot of people just use this by inspection and they were able to figure out what number went there. But this equation says the exact same thing. Start at 20, add x 1, 2, 3 times, and you get 38. So 20 plus 3x equals 38. Now I'm going to solve this for x, and we get 3x is equal to 18. Divide by 3, we get x is equal to 6. So now the last part of this is probably a good idea to check. So we add 6, we get 26. We add 6, we get 32. We add 6, we get 38, and it works out. So the explicit formula is to get the nth term, you start at 20, and you add 6, n minus 1 times, one fewer than the one you're aiming for. A geometric sequence has a first term of 8 and a fourth term of 216. Same setup. Eight, 216. But it's geometric this time. So that means it's a multiplicative pattern. So we're multiplying by some number r each time. So if I want to set this up algebraically, we could say 8 times r times r times r gives us 216. It's a better way to write r times r times r. It's r cubed equals 216. And now solving for r here, we divide by 8. We get r cubed is equal to 27. And then we're wondering what number cubed gives us 27. Well, then r has to be 3, because 3 times 3 times 3 is 27. So you can check it again, like we did before. 8 times 3 is 24. 24 times 3 is 72. 72 times 3 is 216. We want an explicit formula for a sub n, the nth term of the sequence. So a sub n is equal to start at 8 and multiply by 3 a bunch of times. In fact, one fewer than the number you're aiming for is times. Determine the sum of the first 12 terms. So for this part, when we sum it, it's no longer a sequence, it's now a series. So we use our geometric series formula. And we plug in everything to the formula. So we do a1 minus a1r to the n all over 1 minus r. And that's s sub n. So s sub 12 is equal to 8 minus 8 times 0, no, times 3 to the 12 terms, so 12th power, all over 1 minus 3. And I remember when you plug this in the calculator, you have to put parentheses, and you should be getting the correct answer when you do that, but I don't have the calculator in front of me. Which of the following is the value of that? We start by evaluating the big sigma part. N equals 2, 3, 4, all the way up to 5. So when we plug in 2, we get 2 minus 1 to the 2 minus 2. And if we use parentheses on our calculator, we get 1. Here we get 3, if we use parentheses correctly. Here we use 4 minus 1 is 3 squared, that's 9. Here we use 5, so 5 minus 1 is 4, 5 minus 2 is 3, 4 cubed is 64. We sum these all together and we get 77. Or do we? I think we get 77. Yep, we do. And now we do 4 plus 3 times 77. And that gives us 4 plus 231. Is that right? Maybe I made a mistake. Let's see. 3 times 77 is 1, 2, 2, 3. Wait, 3 times 2, 3, 1. I'm getting 235. Let's see. It's 1. 3 minus 1 is 2 to the power of 1. This should be 2. Let's just plug that one in one more time. 3 minus 1 is 2. 3 minus 2 is 1. That should be 2. So that changes things a little bit. This looks like it's 76. So 3 times 76 is, let's see, 8, 1, 228. 228 plus 4 is 232. Sorry about that, guys. It is problem 2, or choice 2. Which of the following is the sum of the numbers from 1 to 321? Okay, this is a throwback a bit to a problem we touched very briefly on. But if we added all the numbers from 1 to 321, we could say that that was a sum of 321 numbers. Now, frequently when we have these summations, we use the geometric series formula. But there is no geometric series here because it's not multiplication. It's actually just going up by 1 each time. So we have to use a different method to solve it. We're going to use the forwards, backwards method. So we'll write the exact same series of numbers below. 321 plus 320 plus 319 plus 2 plus 1. But we're going to write it forwards here and backwards here. Now we sum these two equations together. That gives us 2 copies of this equals 322 plus 322 plus 322 plus 322 plus 322. So we have 321 of these. So we get 2s 321 is equal to 322 times 321. We divide by 2 on both sides, and that gives us s 321 is equal to 51,681. Cool. Which of the following is the sum of the first 13 numbers in the sequence shown below? This is just a geometric series problem. I'm going to let you guys solve this one on your own and do some of the harder ones on the back. After dying, a rich real estate tycoon needs $10,000 in a trust fund for their grandchild. The trust fund earns 5% interest each year. This means the value of the account increases by 5% each year, and no new additional money can be deposited in the account. If the grandchild is 1 year old when the money is deposited in the trust fund and must wait till 30 to withdraw the money, then how much money will be in the account when they can withdraw the money? So it looks like when they're 1 year old, there's $10,000 in the account. When they're 2 years old, it earns 5% interest, which means we have 100% of what we had before, plus an extra 5% interest, so 105%. As a decimal, that's 1.05. That gives us 10,500. Times 1.05 will give us, for the next one, $11,025. And we want to go all the way up till A30. Sounds like an explicit formula will be really useful here. So we start at A1, 10,000, and we multiply it by 1.05 a bunch of times. To get to the third, we multiply by it twice. To get to the 30th, we multiply by it 29 times. So A sub 30 is equal to 10,000 times 1.05 to the 29th power, 41,161. So the account has grown tremendously in those years, from $10,000 to $41,161. This is a little bit of a benefit for why saving money is useful. Or saving money in the proper retirement accounts, proper interest-bearing accounts is useful. For this problem, round your answers to the nearest whole dollar. Laura makes $42,000 in her first year at a job. Each year she earns a 7% raise, so it's 100% of what she had before, plus an extra 7%. So you get 1.07 times as much each year. I'll let you guys figure out these first two. So you do part A. For part B, in her 25th year, we'll take her $42,000 initial salary and we'll multiply it by 1.07 24 times, 24 steps between these two. To the 24th power, I think, 213,039. Dollars. And now for part C, how much will Laura earn in total over the course of her 25 years working at the job? So that would be all of her salaries added up. And when we add these things up, that makes it into a series, which means we now have unlocked our geometric series formula. So S sub 25 will equal A1 minus A1 times R to the nth power all over 1 minus R. $2,656,460. $2,656,000 $460. Quite a bit of money made over her career, but also maybe a little bit depressing to think that that's all you make in 25 years at a job. I don't know, is how you interpret it. But anyway, it's a great geometric series application. So see you guys in class tomorrow.